mechanical system. And this mechanical system, we are interested to find the transfer function and or transfer functions, you may say. The transfer function needs to define an output and an input. So I am going to see the example that we have is the question in here says find the transfer function that relates x1. So this is the motion of this to the force. This is what we want. So keep in mind the force acting on the mass in the displacement in relationship to the force input. That's our challenge that we have. All right. So I'm just so that I can perhaps write it down in here objective. Okay. So you want the transfer function. This is the relationship between x1 of s to the input force, this F of s. This is your objective. All right. So let me disappear from here and we'll proceed with this. All right. So in order to build the bond graph model of this, I need to recognize the distinct velocities here, and I'm going to say, look, this is one of those, the velocity of the mass, and here this x1 dot. You know also this one is another velocity. This is x2 dot, like that. So what I would do is just to make sure we are on the right track here. This is the reference point. This you know, the floor. But for now, let's just put those two velocities. One for x1 dot, and you have another one for x2 dot, like that. Okay. Do you remember the step number 2 is? Step number 2 says write the or attach the elements that see those velocities. So this one, obviously, you have the I element with value m sub 1. On this other one, you also have an I element with value m sub 2, right? Okay. Now, we also have an input source, which is the force in here. This is the value of this is what? The value of this is f of t, like this. Yeah. And so you see the there's obviously a difference here that you can say that this element and this element, see the difference between this and this, but there is a little bit of a major difference. You say there's not a little bit, but there's a major difference than if this damper and the spring would be side by side. Because you see what's happening is that the force on the spring is transmitted over here. So the force is the same, but the velocities are not. So in this particular case, you can say, okay, this is the 0, and then you say, okay, this is the difference between this. but they see the same force. So this should be the I element over here, like this. Not the I element, this is a C element, excuse me. This is the C element. So, which is the spring here with value 1 over K. And then this other one would be the R element with value FB sub 3. See? Now, there is some consideration in here. Do you see this in here, that the problem is asking us to consider the friction, and it's also asking us to consider the friction between these two. So the friction between this element and this, so that has to see the relative velocity. So in here, I think it's important to address both of this, because you see right now I realize that we need to create the relative velocity between them. So in here, the velocity x1 and between x1 and an x sub 2. So if this would be like this. And this is this R with value FB sub 2, like this. Okay. And finally, the velocity between this and the ground. So I could put the velocity of the ground as another one junction in here. This is equal to 0. And then of course you could put it like a source of flow with velocity equals to 0. And you see, I am trying to model this in here. So this would be the difference between this would be x sub 2 minus the velocity of the ground. And in here we put this R element with value FB sub 4. Okay? So that's it. I have done a very complete graph right here, but for purposes of finding the transfer function and simplifying this, we could basically suppress all this on the right hand side, because we have this this velocity equals to 0, and this R element would go into this on this side in here. So what we could do is, well, let me make sure that we complete this correctly, like this. Yes. Of course, in here we have seen that we have this over here, which is in fact all this region here. You could simplify it, or you could leave it like this. We could do it both ways, but just to show you how the simplification would go, I'm going to draw the simplified graph on the side in here. It would be like this. This would be I, and then this would be the SE. And then you have this 0 with the C and the R element over here, and then this 1 with the I element over here, and this entire thing, because this is 0, is like it doesn't exist, and therefore this R goes over here. This would be the simplified graph that I have. So we still have this one right here, which we need to do, and then like that, and then this R, and then this R, and then this will be R over here. Let's try to put this into the CampG software, and we would give it some numbers. In fact, you could enter this into any order you want in the CampG, but then you have to recognize which elements you have to do your yeah.
Professor, why did you replace that the N with the R again? When you simplify it?
Because you see, in here, when I simplify, this is 0, right?
Oh, okay.
So this is like it doesn't exist, this whole thing.
Gotcha.
And when you do through power like that, then only this R element over here. So let's try this. We'll put this into the CampG software, and let's just make this into a window. And of course, we'll go and run the program. Let me just close some windows so that they're not relevant in here. And so in here I will go, and this is right here, and so we'll do this very efficiently so that we enter this in an easy way. Let me see. We need this, and I'm going to make it small enough. Ay, ay, ay. Yeah, there. Yeah. Okay, so we have in here we have, well, let's just do it from left to right. So I just put in here, this is the 1, and then I put the I element over here, yeah, and then I put the 0 right here, from here to here, and then I put the C element over here, like this, and then we put the R element over here, like this, and then the 1. Do you see this goes pretty quick? And then I have the I element that is over here, and you put from here to here. Then you have the R element that is here, and you go from here to here. Then you have the 0 over here, and then you go from here to here, and from here to here, and then we have these 2 R elements in here that go from here to here. The other R here.
Professor?
Okay, hold on for a second. There's a small correction I think we need to do for that R element. We don't need 2 R's on the 0, but rather one element that has both of them. We need to make a small correction. So let's just do it here. This we don't need two of this in here because it would imply the forces the same, and well, actually the forces are getting added. So we have another element that has two of those, has two values. Or perhaps to make it more clear, we could do this. That difference is yeah, small correction here. If you do it like this, then you can put the two R's. There you go. I was going to put just one with adding the two parameters, but I think this would be it would be clearer in here. So let's just go over here. See, you could do this. You could eliminate one and then have double, the sum of both, or you could do it like it's on the left hand side. I think to be totally consistent on that, I am going to do it like yeah, right here. Okay, see here, delete. We're gonna delete this one. We need to put the 1 in here. This is perhaps much more clear. And so we put it like that, and we put the other R on the other side like this. Okay, now what to do? Everything is assigned perfectly well, no red marks, no nothing. What is the transfer function that I am looking for? You have to recognize on the bond graph the velocity that I want is F2, and the force is E1. So the input is E1 and the output is F2. Let's write that down because that is going to be important for the computer program to give me the answer. Alright, so I am going to go in here to the interface of MATLAB and say okay, please go over here. Okay. Yeah.
Why do we know it's F2 and not F3 or F9?
F2 is the value of the flow, the velocity of the mass. That's why. So we are ready to obtain our transfer function. On the right hand side, we have that F2 is the output and SE1 is the input. So we go into the interfacing here and go to MATLAB, and then we need to obtain the interface. So